Alright, so in this particular video, we have two people that are pulling on a boat. It says through the water, as shown below. It says each person exerts a force of 600 newtons directed at an angle of 30 degrees, okay, relative to the horizontal axis here, the forward motion. So the forward motion is where my cursor is going back and forth, aka along the x-axis for this one. It says if the boat moves with a constant velocity, find the resistive force. So here is this vector F pointing in the leftward direction, which is against the direction of pull. All right, so let's go ahead and do it. In order to do this one, pretty straightforward. Since it says constant velocity, this one makes it pretty easy. The first thing you should do is identify the horizontal components of each of these apply force. So you have this person here pulling kind of upward and to the right with a 600 Newton force. The angle here is 30 degrees. And then at the same time, you have another person pulling with equal magnitude of 600 newtons in the southeast direction. But both of these are symmetrical because the angle theta is 30 degrees at the top here and also 30 degrees at the bottom. So here, this is f of x. It's f of x because the vector that is blue, that is your applied force, which in this case I'll just call f. And then this dash component is f of x because it's pointing along the x-axis. Since this is a top view problem, the horizontal axis is this, and then the vertical axis is this, okay? Therefore, the next arrow we should draw out is the component of the bottom force that's being pulled, which is a diagonal. So you notice here in this diagram, you have two people pulling, but they're pulling in a diagonal relative to the horizontal axis. So each force has to have its own horizontal component. So here we call this Fx. This is 600 newtons. The bottom force is also 600 newtons. So here I'm not using any subscripts. I'm just going to call it Fx. And then the bottom also has an identical Fx. And since it asks us to find the vector F here that the water is acting against it, we can just set up Newton's second law in the horizontal direction. So here in my statement, I have the net force in the x direction, which is equal to max. The reason I'm focusing in the x direction is because the resistive force here is along the negative x direction. Okay, so therefore I already have my two horizontal components, fx on the top vector and then fx on the bottom vector as well. So what I can do is I can add up these two horizontal components. So there are two fx's because there are two people pulling diagonally. So therefore the top fx is identical as the bottom fx. Here I just wrote out fx plus fx, and then I want to subtract it from the force that's acting against the direction of pull. All right. Here, if you wanted to, because both of these forces are 600 that's being applied, and the angle is the same, you could have just written out 2fx if you like, because fx plus fx is 2fx. But I just wrote out as fx plus fx minus f just to help you visualize all three horizontal forces that are being applied on this particular boat. Okay, so if you count, there's one arrow, there are three arrows along the x direction, so there are three terms. Well, what I can do here is I can find what fx is, right? You have enough information to find what fx is. It says each of the persons pulling with 600 newtons, so therefore I can find fx by simply applying cosine. At the bottom of the screen here, I said cosine of theta is equal to adjacent over hypotenuse. Well, f of x is your adjacent relative to this angle that's given because it touches the horizontal axis. And then the hypotenuse in this case would just be the force that's being applied, which is 600 newtons. So to solve for fx, multiply both sides by 600. So therefore, we have fx is equal to 600 newtons times cosine of theta. But each of these angles is given as 30 degrees in the wording. Okay, so theta is 30 degrees. So I'm just going to substitute out theta for 30 degrees. And if you put in 600 times cosine of 30 on your calculator, you should get a value of 519.6 newtons. That's each of these f of x is generating 519.6 newtons in the horizontal forward direction. So therefore, I'm just going to substitute out f of x for 519.6. I'm going to do that twice since there are two terms here. Once again, you could have written out 2 times fx if you choose to for this problem because of symmetry. I'm going to subtract f because I don't know what f is. That's what the question asks you to find, the resistive force. And in here, you notice I replaced ax with 0 because it says constant velocity. Constant velocity implies that the acceleration is 0. Okay. So therefore, the only unknown here is your variable f. I'm going to move negative f to the right side, which makes it positive. And then the left side just has these two terms left. So if we add 519.6 to itself, we should get a value of 1039.2 newtons. And that is your answer. So the resistive force in this case, it has a magnitude of 1039.2, but really is pulling left. So on a technicality, if you want, based on how questions are being asked, you can say F is negative 1339.2. Okay. So what I help you find here is just the magnitude of the resistive force. So if you want to add the direction, say negative because it is pointing left in the diagram. All right, I hope that helps. Stay nerdy, don't be white.